Okay, so I'm going to start with the problem of the day. This is the lesson from Tuesday, May 1st. So it says to solve for y in the equation. And what conclusions can I make about my solution? So I have negative 4 plus 6y equals 8 times negative 3y plus 5. Okay, so now what I have is negative 16 plus 6y. Oh, I made a mistake there. Plus 24y equals negative 24y plus 40. All right, so I'm going to rewrite this so that I can, this is minus 24y, see what's happening here. I have minus 24y minus 16 equals minus 24y plus 40. So I could continue to solve this, but because I have the same coefficient and different constants, this equation is going to have no solution. Okay, and I could see that if I add 24y to both sides, then it's going to cancel on both sides, and what I'm left with is negative 16 equals 40, and that's a false equation. So that's a good example of an equation that has a false solution. So we're going to take a look at some patterns again here. So this is the problem from the problem of the day here, and again that was negative 24y minus 16 equals negative 24y plus 40. So I had the same coefficient, and I had different constants. And so that's what led me to understand that I had no solutions. Okay, here in the next problem, 10x plus 12 equals 10x plus 12. Well, I have the same coefficient and I have the same constant. So what does that lead me to understand? That I'm going to have an infinite amount of solutions. And then here, I have something different for every term. And that's going to lead me to the idea that I only have one solution. Okay, so what I'm going to do now is I have a problem, and the problem says use the equation ax plus c equals 4 times 2x minus 10 minus x plus 7 to answer each part of the question. What numbers could be substituted for a and c to result in the number of solutions identified below? So what I have is ax plus c equals 4 times 2x minus 10 minus x plus 7. So I'm going to simplify this, and then from there I'm going to be able to tell what numbers I need for a and c for no solution, one solution, or many solutions. So ax plus c equals 8x minus 40 minus x minus 7. Okay, you really have to watch that this negative sign gets distributed to both this x and to this 7. Okay, so then from there I can combine my like terms. Ax plus c equals 7x minus 47. So in order for my problem to have no solutions, my a value needs to be equal to 7. My c value is any number other than negative 47. So it could be 2, it could be 10, but it just can't be negative 47. It needs to have a different constant. So for one solution, it can basically be any numbers other than 7 and negative 47. So let's say 5 and let's say 2. And for it to be infinitely many solutions, it needs to have the same numbers. So this would be 7 and this would be negative 47. All right, so I hope that was helpful to you. You have a self-check that you can practice with here. The main struggle that kids had was in simplifying these equations here. So you really have to make sure that you're distributing correctly, including your signs, and that you're distributing correctly here, and then that you're combining correctly. That's what's really important in order to get these problems correct. All right, so good luck with this, and let me know what questions you have.